So today I'll be doing Boyle's law, Charles' law, Gay-lussac law. In our elementary days, we explained the properties of solids, liquids, and gases using particulate nature of matter. We learned that gases are quite different from solids and liquids because they have neither a definite shape nor a definite volume. They completely fill their containers, taking both the shape and volume of their containers. Aside from having changeable shapes, gases and volumes have other physical properties. These are as follows. A gas can be compressed to a smaller volume, resulting in an increase in density. Number 2, gases fill their containers uniformly. Number 3, gases exert pressure. Number 4, gases diffuse and mix with one another to form a homogeneous mixture. That's why we can smell the aroma of coffee or perfume in a room because gases diffuse easily. The pressure of a gas depends on its temperature. The higher the temperature of a gas, the higher is its pressure. The lower the temperature of a gas, the lower is its pressure. This is why the air pressure in tires is periodically checked to ensure safety, especially during hot summer months. The kinetic molecular theory. Kinetic molecular theory describes the behavior of a gas at the microscopic level. The followings are: gases are composed of very small particles called atoms or molecules. There are no opposing or attractive forces between gas particles, and gas particles are in constant random motion. Gases occupies negligible volume. Boyle's law came from a British chemist in 1662. This is Robert Boyle. He found that the volume of a gas decreased as the pressure was increased. For example, doubling the pressure caused the gas volume to decrease to 1/2 its original volume. So that's all. That's an introduction about the gas. So let's move on to the first law. The first law is Boyle's law. It is pressure-volume relationship, inversely proportional. In short, the relationship of pressure and volume according to Robert Boyle is... So let's get started! The volume of a fixed quantity of a gas is inversely proportional to pressure. So we need to put the marshmallow in. We need to remove it and put here. Put the marshmallow inside the syringe. Like that. So for today's experiment, I'll be doing Boyle's law experiment. Syringe. We need syringe and a marshmallow. So again, I'll be doing the Boyle's law experiment. Look, observe the first volume. Now, as the pressure decreases, as you can see, the volume increases. Again, as the pressure decreases, the volume increases. Yeah. And as the pressure increases, the volume decreases.
So again, I'll be
doing the Boyle's law experiment. Look, observe the first volume. Now, as the pressure decreases,
as you can see, the volume increases. Again, as the pressure decreases, the volume increases. And as the pressure increases, the volume decreases.
so we'll be needing this one. It must be a glass. Next, a glass cup. So that is the explanation for Boyle's law. So check for Robert Boyle's. And lastly, we need a water. Of course, we need matches, a candle, we need a food color. So we'll be needing a candle and a piece of match. You need, the first thing to do is to light the match, the candle. Be careful because we are using fire. As I said, we need water. Next, we'll be using the food color. Let's open it. Here it is, and put a little bit into the container with water. Next is to mix it. You need to mix well. They use a food color so we can see how the volume change. So, wow, it smells good. Look at the volume. Look at the volume. It doesn't have a light yet. The next thing to do is we need to light the candle again. The next thing to do is we need to make sure that the candle will not fall. So that's why we are doing this. We need to put this one and put the candle and turn it. So after we light the candle, we will be using the glass and we need to put it in the lighted candle. As you can observe the volume, wow! So that is the first volume.
Whoa!
Shape of it is inversely proportional. It means as the temperature increases, the volume increases, and as the temperature decreases, the volume decreases. Charles' law is a relationship between temperature and volume. Charles' law came from a French physicist and a Ballonese, which is Jacques Charles, in 1787. Summarized the effect of temperatures changes on the volume of samples of gases at constant pressure. From his experiments and those of other scientists, he stated that the volume with a symbol V of a fixed amount of gas N is directly proportional to its temperature T. If the pressure P is kept constant, this is known as Charles' law. So guys, hope you enjoyed the video. Bye-bye!